slightly upfield. So both the signals will exist side by side. Now, if you have understood what is splitting, let us see the rules for signal splitting. Spin coupling. Okay. So peak. First rule: the units into which an NMR signal is split, it's called as peak. Doublet, triplet, quartet, multiplet, and so on. Then signal splitting. Splitting of an NMR signal into a set of peaks by the influence of neighboring non-equivalent hydrogen is called as signal splitting. Next, it is a rule. It is called as N plus 1 rule. It is also called as a rule for signal splitting. If a hydrogen has N hydrogens non-equivalent to it, but equivalent amongst themselves on the same or adjacent atoms, its H1 NMR signal is split into N plus 1 peaks. I will give you example for this. Okay, consider this hydrogen HA. Now in the chat box, tell me this hydrogen HA has how many hydrogens that are non-equivalent to it. HA has how many hydrogens non-equivalent to it. We have already seen how to calculate equivalent hydrogen, how to find that number. Okay, excellent. Meg, Priyanka, Kajal, very good. Pooja, Riddhi, Namrata, very good. So the only one non-equivalent hydrogen is hydrogen B. So for HA, if number of non-equivalent hydrogen is only one, so for HA, how many signals will be observed? N here is 1, non-equivalent hydrogens are 1 and plus 1. So for HA, you will observe a doublet. Now, for HB, how many hydrogens are non-equivalent? For HB, how many hydrogens present which are non-equivalent? Excellent, Priyanka, Daksha, Sonali, very good. So these three hydrogens, okay, these three hydrogens are non-equivalent. So N plus 1 for HB it will be 3 plus 1, 4. So you will observe quartet for HB and doublet for HA. I hope this rule is revised for you people. You have solved problems based on this in your final year examinations. Okay, so in front of you is one example of NMR signal. This is actual signal. You can see the integration of the area under the curve. Observe whatever given in the slide, given on the slide. I will explain it shortly, but you try to observe it. You may zoom into that slide. Okay, so the compound is CH3 CH Cl2. It is 1,1 dichloroethane. Okay, so this is HB set of proton and this is HA set of proton. So these are the corresponding signals. Okay, so for HA there is one non-equivalent proton. So 1 plus 1, 2 peaks are observed. You can see 2 peaks over here. And for HB there are 3 non-equivalent proton. So 3 plus 1, quartet is observed over here. Okay, the chemical shift of proton HA is affected by the spin of its neighbor. So we are considering HA. Its spin is affected by this HB. How it is affected? Let us see that. Okay, whatever number of molecules are present, suppose there are 1000 molecules present. Out of 1000, there will be 50% molecules, that is 500 molecules, who will align themselves such a manner that the spin of this hydrogen is aligned in the same direction of external magnetic field, and in the remaining 50% of the molecule, the spin of this hydrogen, this nuclear, will be such that it is opposite to that of the external magnetic field. So when it is aligned, when this is the case, then there will be more de-shielding. So the signal of HA will be downfield because there will be more de-shielding for HA. In this case, the shielding will be less because this is opposing the external magnetic field. Okay, so HA will experience slightly less magnetic field, so there will be less de-shielding, or I should say there will be shielding. Therefore, signal of HA will appear upfield when neighbor is opposing the external field. Have you understood it, students? Please tell me, have you understood it? If you have any doubt, do ask. Anybody with the doubt, please do ask. Okay, I am now changing my window to PowerPoint presentation again. If anybody has doubt, please unmute yourself and ask your doubt. Please don't hesitate. Okay, so this is a diagrammatic representation. Sometimes it is also called as a tree diagram. How you are observing the doublet, that is explained. The HB can feel the alignment of the proton, alignment of the adjacent proton HA. When HA is aligned with the magnetic field, HB will be de-shielded. When HA is aligned against the magnetic field, HB will be shielded. So you get such a manner two signals. So therefore the signal is split into two and is called as doublet. Now let us consider the example of triplet. Okay. Now the triplet is observed for proton HA. So it is getting coupled with this particular HB and this particular HB. Since there are two protons, these two protons may align themselves as both of them are in the direction of the external magnetic field. Second case, one is in the direction, the other is in the opposite direction. Third case, first one is in the opposite direction, the second one is in the direction of external magnetic field. Fourth case, both of the protons are aligned such that their magnetic field is opposing the external magnetic field. Now, case number 2 and case number 3, they are equivalent. These two cases are equivalent. One is opposing, the other is assisting. So, when both HB are aligned with the magnetic field, HA will be de-shielded. So its signal will be downfield. It is more likely that one HB will be aligned with the field and other HB is against the field. The signal be at its normal position. So basically what is happening is the effect because of the neighboring proton is getting nullified by themselves. One is opposing, the other one is assisting. So net effect is zero. So the signal will be observed at its normal position. When both HB are aligned against the magnetic field, HA will be de-shielded. Okay, HA will be de-shielded. So the signal is split in three and it's called as triplet. So this is the overall view. Okay, this was regarding a triplet. Now let us see how the quartet is observed. Okay, how the quartet is observed. When we were looking at this particular structure, we observed a quartet here. Okay, so let us see how that quartet is observed. Okay, so origins of signal splitting. The origins of signal splitting pattern. Each arrow represents an HB nuclear spin orientation. Now, and we are observing signal of all HAs. We are observing signals for all HA. In first case, HA has only one neighbor, non-equivalent neighbor, HB. So you will get splitting of signal into doublet, 1 plus 1, because this is n. Okay, so n is equal to 1. So 1 plus 1, you will get a doublet. And this is the intensity of the signal, 1:1. In case where there are two hydrogens which are non-equivalent, so n is equal to 2, you will get a triplet. We have seen this in previous slide. So intensity is 1:2, 2:1. If there are three adjacent non-equivalent protons, in that case the intensity will be 1:3:3:1. The possibilities we can discuss such as all three protons are aligned in the direction of the magnetic field. Then there will be three possibilities where one of the proton is in the opposite direction while other two are in the direction of external magnetic field. Then there is a case where two of the protons are opposing the direction of external magnetic field and one is assisting it. And lastly, all three protons are opposing the external magnetic field. So here you have one possibility, here you have three possibility, again you have three possibility and one possibility. So the ratio will be split in as 1 is to 3 is to 3 is to 1. Observe this diagram. If you have any doubt, please do ask that doubt. Okay, let's move on to next slide. Rules of splitting of proton signals. Now you have seen these rules in final year. I will emphasize on only difficult rules. Easier rules, I am sure you must be remembering them already. Equivalent protons do not split each other. Protons bonded to the same carbon will split each other if they are non-equivalent. It is complementary or extension of the first rule. Protons on adjacent carbons normally will split each other. Protons separated by four or more bonds will not split each other. And this is the rule for a ratio of intensities of the signal. If it is a singlet, there is no question of ratio of intensities, will be a singlet. If it is a doublet, the ratio will be 1 is to 1. In case of triplet, the ratio is 1 is to 2 is to 1, and quartet 1 is to 3 is to 3 is to 1. Now, how the ratio, this is called as Pascal triangle. It is actually very simple to write. You start with 1, then on either side of the 1 you write number 1 again. Then for third you start with number 1. Next number is addition of two numbers of the previous line, and again you should end with 1. Then for third line again start with 1. Next line is addition of numbers immediately in the above lines, and write 1 again. So start with 1, end with 1. In between you have additions of the number. I hope you got it. So you may have up to octet. इतना कॉम्प्लिकेटेड नहीं आता है, जनरली सेप्टेट तक पूछते हैं. ओके, नेक्स्ट कंसेप्ट इज कपलिंग कांस्टेंट. आफ्टर दिस कंसेप्ट वी विल स्टॉप for today. Coupling constant is when the signal is split. It is observed that the distance between the split signal every peak is same for the adjacent protons. Okay, so it is a fixed value. It is a fixed value, and if in a compound one set of proton is coupling with other set of proton and they are splitting each other, the distance between the split signal is same for these two groups. So by observing the distance between the split signal, you can estimate which two hydrogens set of hydrogens are adjacent to each other. The coupling constant J is the distance which is measured in hertz between the peaks in multiplet. It is not dependent on the strength of the external field. It is independent of the strength of external field. J is measure of the amount of interaction between the two sets of hydrogens creating the multiplet. Stronger the interaction, larger is the J value, coupling constant value. There are types of coupling constants now. We will see these types in the next lecture. Vicinal, geminal, cis, trans. You can identify what type of hydrogens are involved. Okay, anyway, today we will stop here. I have already taken your attendance. Those who have not given